Hello, tonight our lesson is on equal values method for solving systems of linear equations. This is part 2. So remember from part 1 that graphing is only one way to solve a system of equations, and that the other way is an algebraic method that we call equal values. Alright, here's our first example. So both of these equations are equal to y. Therefore, we can set them equal to each other. So we have x plus 9 equals negative 4x minus 1. And now I can solve this by getting the variable all by itself. So I would start by adding 4x to both sides. Alright, this would give us 5x plus 9 on the left, and then negative 1 remains on the right. Since my variable is now on the left, I'll subtract 9 from each side. So we get 5x equals negative 1 subtract 9 is negative 10. And now divide both sides by 5. We get x equals negative 2. Alright, so you remember what we do after we get x. We substitute that back into one of the equations and then get the value of y. I'm going to choose to put negative 2 back into the first equation in place of x. So that would be y equals negative 2 plus 9. Negative 2 plus 9 equals 7. So the y value is 7. Alright, so my answer is going to be the ordered pair. X is negative 2, y is 7. So remember, if we were to graph these, that this would be the point of intersection of the two graphs. It's the point that is a solution to both equations. Alright, now this example, the first equation is solved for y, but the second one is not. So we need to solve the second equation for y, and then we can employ the equal values method. So what I need to do here is I need to add 3x to both sides. Then divide both sides by 3. And when I divide both sides by 3, everything gets divided by 3. So that will give us y equals 9 divided by 3 is 3, and then 3 divided by 3 is 1, so 3 plus x. Alright, so now I can set the two equations equal to one another. 3x plus 5 equals 3 plus x. Okay, let's subtract x from each side. So we get 2x plus 5 equals 3. Subtract 5 from each side. So 2x equals negative 2. Now divide by 2. So x equals negative 1. Now I can substitute negative 1 into either equation. So if we put it here, 3 plus negative 1 equals 2. So the solution, the ordered pair, that would be the point of intersection for these two lines, is the point negative 1, 2. Okay, this example we also need to solve for y. Okay, so the first equation, let's subtract 2x from both sides. Okay, if we subtract 2x from both sides, okay, so this equation will become y equals 6 minus 2x. Now we're going to set that equal to the second equation. So 6 minus 2x equals 4x plus 12. From here, let's add 2x to each side. That gives us 6 equals 6x plus 12. Now let's subtract 12. So we get negative 6 equals 6x. And now divide by 6. So negative 1 equals x. Now substitute negative 1 into either equation. I think I'll put it back into this equation. 4 times negative 1 is negative 4. And then negative 4 plus 12 equals 8. All right, so our point of intersection is negative 1 comma 8. All right, we have one more. Let's go ahead, and the second equation we need to solve it for y. So we're going to add 4x to both sides, then divide both sides by 2. So we get y equals negative 5 plus 2x. All right, let's set the equations equal to one another. 10x plus 27 equals negative 5 plus 2x. Subtract 2x from both sides. Now subtract 27. So negative 5 minus 27, that's negative 32. Now we're going to divide both sides by 8. So we get x equals negative 4. All right? Now substitute that into either equation. Let's put it back in this one. So 10 times negative 4 would be negative 40. Then add 27. All right, so that would give us negative 13. So the solution is x is negative 4, y is negative 13. That's all for tonight. Read some books.